Hello, my friends. Welcome to the YugabyteDB community webinars. Please let me know if you can hear me, because today I am the only one on the stream. Looks like something. Frank is always supposed to join me, but we had the clock shifts, the time shift, throughout the last 2 weeks in the United States and Europe, and I have a feeling that there is some kind of issue, time-related issue on the Frank's calendar side. That's why he is not here in this virtual studio today. But hopefully, it's not gonna be a big deal. We will start because and then hopefully Frank will be able to join us. I think that everything should be fine with him, but I tried to raise the flag and contacted him over the few channels. Nevertheless, for those of you who are watching us live here for the first time, this is the platform, Community Open Hours. This is the place and time where you can come and ask us any questions that are on your mind. And those questions certainly need to be about YugabyteDB or PostgreSQL. We always select some of the topics and sessions for our live streams. Today, we are going to talk about MVCC internals in PostgreSQL in YugabyteDB, but we also encourage you to ask your questions that are unrelated to the main topic, because we can always, let's say, find time for what bothers you. So as long as I'm doing the housekeeping today, let me see if we have any questions on LinkedIn. Yep. Thanks, Anjuman, for confirming that you can hear me. Wonderful. So usually how we start with our regular segment when we share with you the latest updates in the world of YugabyteDB. So what happened throughout the last 2 weeks since we met last time? Let me share my screen. Which one I want to share? I want to share this one with you. So first thing first, those of you who follow YugabyteDB closely, you know that in addition to the YugabyteDB community openers, we have another regular technical talks that happen weekly, YugabyteDB Friday Tech Talks. And we had our 100th episode. And that episode, if I'm not mistaken, took place the last week. Oh, it's happening this week. Oh, it's like a big deal. I don't know like when it was. Is it coming, or is it has it already happened? Because yeah, we don't have a counter here. But YugabyteDB Friday Tech Talks is a wonderful place where you can come and learn more about YugabyteDB internals from those who built YugabyteDB. YugabyteDB certainly comes with various wonderful resources that you can find on our website. It can be developer hub, it can be technical documentation. But if you'd like to hear some thoughts and insights from those who build the database on a daily basis, or those who take this database and help other customers to use it for various production use cases, YugabyteDB Friday Tech Talks is the way for you to check and to go. So congratulations to all of those on the YugabyteDB team for making this happen. We have our 100th episode and many more to come. So what else? Also an interesting thing that happened over the last a week, Frank and I, we eventually met in person, and that took place at the Scale conference in Los Angeles. Scale stands for Southern California Linux Expo. And basically this time, and probably the previous times, there was a dedicated track for PostgreSQL. So 3 days, or 2 days, yeah, the track for Postgres was running 2 days, 2 rooms, pretty packed. Folks from the broader Postgres community joined, and you could learn a lot about Postgres and its ecosystem, including YugabyteDB. And that was a wonderful experience. And eventually we saw each other with Frank, and probably today he decided, not just to take a break from that in-person encounter, and that's why I'm streaming alone. Anyway, yep, and hi Pete. Yeah, this time sync up is always an issue during the changeover to from days saving time, and I think that's what we encountered today. Because Frank, as I said in the beginning, supposed to join us, but I believe that probably he will join us in 20 or 30 minutes, and that will be the perfect time for him to come. because how we structured our hands-on demo today. I will begin with the Postgres MVCC internals. I will show you how Postgres enables all of those transactions that run in parallel. What are the mechanics that are used by the database internally, and then Franck will show us how MVCC is implemented in YugabyteDB. Literally, we are going to look into the structure of the write-ahead log files, of the data files, and other things. Next, from the updates, apart from Scale, where we met with Franck, and hey, Palather, hopefully, yeah, I pronounced your name right. Thanks for joining, and feel free to ask questions that are on your mind that are related to YugabyteDB or Postgres. So another quick updates. If you folks are, I think that those of you who are on this line, you certainly came here to learn about YugabyteDB, but also I believe that at least you know or probably already use Postgres. And if you want to learn more about Postgres, what's coming in the next month, in April. If you live in Silicon Valley, in San Jose, San Francisco, other areas, make sure to join this conference. This year, the conference will be running 3 days in a row. So there was so many demand. There are big sponsors, and the schedule is very packed. And this is just, I think, the schedule, yeah, for all of the days. So probably just for the first few. So generally speaking, make sure to come if you live in Silicon Valley. That's a great opportunity to meet and learn about Postgres, the open source Postgres, as well as other solutions from the ecosystem. Certainly, you will hear talk from Amazon, from Google Cloud. You will hear talks from me about YugabyteDB, about like AI, generative AI applications that you can build with Postgres. So it's very interesting impact. What happens after April 17th and 19th? This is Distributed SQL Summit for Asia and Pacific. This is the conference by the YugabyteDB community, by YugabyteDB, where you will learn how to use the distributed version of Postgres, YugabyteDB. So I will share all the links with you folks in a moment, and you will be able to register if you are interested in any of these events. And lastly, in April, we have PG Day in Chicago. It's on April 26th. So if you live in Chicago area or greater area, if you're not that far from that place, also make sure to join. It's just one day, but the talks very good and very technical. And I also will be able to join this event this year. I will be speaking. So it's an opportunity for us also to meet. We'll be happy to see all of you who will be able to make it there. So now, let me stop sharing the screen. And I want to, before we go to the next chunk, I want to show all these links with you. But first I need to find them because, my friends, I have so many tabs open here. All I need to do is this. I'm jumping to the comments. I'm sharing this on YouTube and other platforms, and then I'm also sharing this on LinkedIn. Okay, now you have it. Now you have all those links, whether you're watching us on Twitch, YouTube, or LinkedIn. So let me check the questions. All right, yep. Palather, looking forward to some code implementation. Yeah, I will show you. We will show you internals today. That's the right place and time. Thanks for making it. And hello, Eshwar. It's nice to see you again. And thanks for coming, and thanks for learning together with us and with the broader community. Now, the main topic, MVCC. I think that those of you, before we start, right, just to put everyone on the same page, MVCC stands for Multi-Version Concurrency Control. This is one of the approach that is used by databases such as PostgreSQL to ensure transactional consistency of your data when you execute multiple transactions and queries in parallel. Because get what, it's one thing when you just start your database instance and just connect to the database instance from your favorite SQL tool and run a few requests, and that's probably going to be one request. But once you start putting and using a database for your production workloads, guess what? All those applications are going to connect using, let's say, dozens and hundreds, sometimes thousands of connections, and they're going to execute hundreds and thousands of requests in parallel. And certainly most of those applications that use PostgreSQL these days, guess what? They are transactional applications, meaning that all those transactions that run in parallel, they want to work with a consistent view of data or with consistent snapshot of data. Nobody wants to see something that is not yet committed or partially committed, etc. And MVCC is one of the approach that is used by Postgres and by other databases. So it's a kind of quick background, and now I will jump to my terminal window and we'll start showing you how it works in practice. Again, I need to, and also feel free to ask your questions, because what I will be doing, I will split this into several chunks. I will show you, then I will be checking the questions on LinkedIn, on YouTube. And if there is anything, I will be able to clarify, because we have enough time. Especially if Frank will not be able to join us, we will have much more time for Postgres than I expected. All right, where is my present button? We are going back to the following screen, and enough for the browsers. Where is my terminal window? Let's start with this black screen. I don't know what you think, but I know that we have all those serverless databases, and probably what I need to do is to make this screen even bigger, right? So that you can see the text. I know that you can deploy Postgres as a serverless database. It's all easy. You use a database connection. But for me, the easiest way to deploy Postgres is Docker. It costs nothing to me. I already have my laptop, and it's paid. I don't need to pay any fee to a cloud provider. And I deployed Postgres, the latest version of Postgres. It's, I think, Postgres 16. It runs on my Docker environment. And we are going to use this one. And my goal is, I will share instructions with you. So you don't need to take screenshots of what I'm going to do. Just try to make sense of what I'm showing. If anything doesn't make sense to you, then ask a question, because in the end, I will give you all of those instructions with some, high-level explanation. You will be able to reproduce everything on your step. I even have instructions on how to start Docker, Postgres and Docker, like it's just 3 lines of Docker command. Now, I will be certainly using PSQL. It's the standard tool that is used by Postgres. Let me connect to my Docker container. I know that password user is Postgres, and the password, the password is just password. So I'm connected, Postgres 16. Now let's take a look at our database. There are no any relations. It's just clean and neat database instance. Now, how do we start testing multi-version concurrency control? We don't have any tables. Let's create one. And let's use this boring, but still yet very good example of bank accounts. I will create a table named account. And it's gonna have, just 2 fields, ID of an account of the integer type and balance of the account of the money type. All right, the table is created. And now how about we add our first customer to the database? Let's do insert into account. ID is gonna be 1, and that customer put down $500. Why not? As always, I always do this mistake. I don't know, I always forget to put these values. Probably it's just redundant. I don't know what's your thinking, but I guess that I do it all the time. This exception. Probably we just need to update the SQL standard. So now we have the data, and now let me run this obvious request. I am selecting all the accounts from my table. The star, that star returns all the columns, but it returns all the columns that are visible, that should be visible to your application. Because guess what? Every record, every row in Postgres has a header. And that header stores some hidden columns. And those hidden columns are not visible to you when you use this select star statement. And those hidden columns are used internally by Postgres. And they are also used for the purpose of multi-version concurrency control. The values that are stored in those headers and those columns are needed to Postgres to make sure that you can run transactions safely concurrently without any data inconsistencies. How do you see those? You just need to know the names of those columns. For instance, one of them is CTID, and I will explain you. Another one is xmin, another one is xmax. And I will not get an error. I want to get these columns, and also I want to get all the other visible columns from the account table. Okay, no any exception. Why? Because there are some columns that are not just visible to us. So that's what we see. That's what we saw before. This is what returned by select star. That's our only record. And here is CTID is basically the unique identifier of this row within a page. So what Postgres does when it allocates memory from your operating system, let it be DRAM and storage, that memory will be split into pages. And inside of those pages, Postgres stores your application records. And every application record has some unique identifier. But this unique identifier is not fixed. So don't trust it. It basically can change over the time if you update this record. So xmin stores a value of the transaction that created this version of the record. So 743, that was the next ID for the next transaction that executed this insert statement. Okay, xmax is set to 0, and xmax basically stores an ID of the transaction that deleted this version of the record or attempted to delete this version of the record. As long as the value of xmax is set to 0, it means that this version of the record is not deleted, it's visible, and it will be returned to your application whenever you execute a query like this. So hopefully it makes sense. CTID is a unique identifier of the current version of the record. We have just only one version of the record. Xmin stores the ID of the transaction that created this version, and xmax stores an ID of the transaction that deleted or attempted to delete this version of the record. It's set to 0, meaning that this version is actually visible to all of the future requests. Okay, so I see the first question. I wonder how you're going to show MVCC with 2 or more transactions. That's what I'm going to do next, okay? Stay tuned. Let me check my LinkedIn for any questions. No, looks like the guys on LinkedIn, they get it. Now, and as I said, this is controlled to make sure the visibility of the data across several running transactions. What happens if, let's say, I want to add other records to the database? Okay, let's do this. I'm adding the second account with $600, and also I'm adding the third account with $700. It's obviously was inserted, and now if you request it, take a look. Yeah, this is select star, returns all these visible columns. We have just added 2 more accounts to our table, and take a look at this one. The header of all of these rows stores, some information that is required for MVCC. What's interesting here, xmin is the same for these 2 values. Why? Because when I executed this insert statement, Postgres implicitly, internally, executed this as a transaction, and the ID of this transaction was 744. So this is how it works. Now, to address the question of Palatha, how does it work and why is it necessary, right, if you have, when you execute multiple transactions? And today I don't want to run any PG bench. I don't want to execute, dozens of transactions in parallel. If you want to see the MVCC internals, it will be enough just to have 2 terminal windows, and then you're just running one update, and then you're trying to query the data. Let's split the plane vertically. And also let me check. Oh yeah, Frank responded to me, and yeah, looks like that was the time shift issue. Yes, my friend, let me respond to him, and he will be able. Yes, please join us.
I'm there.
All right, wonderful.
Yeah, it seems that you have changed your time, and we didn't yet in Europe, and then that's 1 hour before for me.
I got it. Yeah, this is what I expected. Yeah, and thanks, Jiva, for clarification. Yep, thanks. I will be calling you this way. Okay, so also, Frank, I just started showing the MVCC internals of Postgres, so you already know what this is about, and I'm answering a few questions. Here, can you give the instructions to check the date from another date for the number of transactions as to check the date from to another date for the number of transactions as per like particular. Probably I don't get this question precisely, but let me get it to it in the end, right? Once I show, probably I will be able to answer what you are asking. If not, we will get back to this question as well. Now, let me connect to this PSQL from another terminal session. Actually, we can do this. I'm connected, and what I'm going to do next here is, let's begin this transaction. And let's say that now I want to select, I want to update the first account. First, I want to see the current value of this account. We all know it. It's just $500, and this is the internal information that is used by Postgres. However, what will I see here if I copy and paste the same request? Take a look at this, right? I still see the same, right? The same value, the same xmin, the same version of the role. Now, if I want to update this account, I'm telling update account table, set balance to 1000. Wonderful. Paycheck. Where ID is equal to 1. So it's updated, but it's not committed yet. This transaction is not committed. So when you execute the same select right now here from the same transaction that is opened, what you see that the balance is already set to 1000, and the xmin is different from the previous one, right? This is the ID of the transaction that created this version of the record. How do you know? How do you find that transaction ID? This is my transaction that is opened right now. One of the options is you can execute this internal function that returns your current transaction ID. And guess what? Yeah, that's my ID, the ID of this transaction. However, what's interesting, this transaction already sees this value. But we have MVCC, and MVCC in Postgres makes sure that this change is not visible to other transactions or other requests that will be queried in the database. For instance, if I execute the same request from here, guess what I see? I still see the previous value, the one that is committed, the one that is visible. Xmin is set this one, but guess here, what do I see here? Xmax is set to 745. It doesn't mean that this version is deleted. It only means that this transaction with this update wants to make this record obsolete. It wants to delete it. This is what's happening, but this has not happened. And now your question is kind of, you probably why don't you want to see, for instance, why this session doesn't want to see the current value that is not committed yet? Why do you think so? Because this transaction might never be committed. For instance, let's say that I aborted this transaction, or there might be some outage, or there might be something else, some exception, and this value was never committed. That's why MVCC doesn't want you to see this value until the transaction is applied. Because right now, let's say, if you execute the same request here, yeah, I no longer see this one, this version, right? I see the version that is visible. And this basically says that no, even though Xmax is set to 745, it doesn't mean that this version was deleted. It means only that there was an attempt to delete this transaction, but it's with this version, but it's still here. And here is obviously we also have the same, like nothing happened. But now let's talk about a positive scenario. I'm starting my transaction one more time. And again, right now, let's say that this balance, the person who got this balance was so lucky that decided to buy something, and right now only has $300 on the account. If you do the select from here right now, what you see, that's the current value, right? The new value, the new version of the role. That's our transaction ID, and this transaction has introduced this value. But here is if I want to get this record from another session, certainly I will not see this because of MVCC. You don't want to see something that is not committed yet. And basically, all these xmin, xmax versions help you to control the visibility, what's visible. So this transaction, right, is not committed yet. That's why you will not be able to see everything that is introduced by it, right? You cannot see it. Now, if you commit this value, so that became the latest value. And same here. So now we're on the same page because the update happened. The question is, what happened to those previous versions of the rows? Are they gone? Are they still there? Frank, like what happened to those versions of the rows?
And for how long? Of
And for
course,
how long?
MVCC must keep them because you may have another transaction that opened a bit before and that must read as of a previous time.
Exactly.
So
Exactly.
they cannot be cleaned up immediately, but at some point you don't want also to have them in 2 years because then your database may grow too much.
Absolutely. Absolutely. The question is now, we are showing the internals. How do we see this? Because what happens right now, whenever I'm selecting this information, or I do this just select star, let's do what usually applications do, right? Select star from account. I don't see anything, right? I just see this data. I don't see other previous versions. But in Postgres, we all know that Postgres has a very broad ecosystem of extensions. One of the ways how you can see or how you can look at those, how you can see those previous versions is install the page inspect extension. Create extension, page inspect. So
And
I
by
know
install, it's just create extension because it's already there distributed with Postgres in the contrib extensions.
Exactly. Basically, that's a good point. You don't need to install this extension separately. It's prepackaged. Probably many people were curious, right, to see at the state of the Postgres storage and memory. And Jiva also, saying like vacuum will clean. Let's talk about vacuum. At least I'm happy that you know what vacuum is, but let's just, it's a little bit of spoiler alert for you folks. But before we talk about vacuum, we need to see what we want to clean. So we installed this page inspect extension, and I have this function. Let me execute this function. I'm using this get raw page method of the page inspect extension to get the first page of the account table. And then I'm getting this raw data from this page, and then I'm using another second heap page items function to convert it to a readable format. And once it's converted, I'm going to get these columns. So this is what we see. Now take a look at this. Let's also do this select star. So here is not just select star. I want to do this select from account. Yeah. So here is this one. These are the two versions for the following two rows, right? The second and the third balance. And then we have three other versions of the rows. What are they? So this one with the xmin equal to 746 is the latest version of the row for the account ID 1. So whenever we, try to credit and debit it. The other versions, like this one and that one, they're no longer needed. One of these versions, I guess this one, was created when we aborted the transaction. You remember we started the transaction, we introduced a new value of the balance with 1000, but then we aborted the transaction. And that version still stored in the database, even though the transaction was aborted. And this was the very first version of the transaction when we just probably created the second version of the transaction, right? That we committed, etc. But we will see, because right now, when you take a look at these columns from the page inspect, you don't have a clear view of when and how every version of the record was created. What we see right now is, even though our application gets three versions when it queries the data from the account table, in fact, Postgres already stores 5 versions of the rows, and 2 versions of these rows are for the account with ID, and 3 versions of the rows are for the account with ID number 1. How can we get more details? If any of you have read this Postgres internals book, wonderful book that was, I think, released a year and a half ago, there was a function. And what this function does, this is just a wrapper around the page inspect. It basically will query your heap page items get raw page. and then it will also read additional flags that are stored in the header of the rows, and then it will be checking special bits. It's like bitwise operation, and then it will be providing us with extra details, like C stands for that version was committed, A stands for that version was aborted, etc. So let's create this function here. So what's the function name again? The name is heap page. Yep. So, and now I just do select from heap page the table name account, and then a range of the pages that you want to get. I just want to get page number 0, the first page. And now take a look at this. So what we have, this is the version of the first row of the account 1 that was aborted, because we have this flag A here, right? Then this is the last version of that account with balance 1, because we use the transaction ID. This is, I guess, the very first version of that account 1. And generally, here as it says, like, if there is any reference to this version of the row, you will not be reading it, because this field says like hard heap update. It means if it's set to true, it means that you need to jump to another version of the row under the following offset. So like you will be jumping to 0.5, and this is the last version of this row. Okay, it's visible because its xmax is set to 0. A heap only tuple means that when it's set to true, it means that this version of the row is not stored in indexes, and basically it's only stored in the Postgres storage. But generally speaking, extra information, extra fields. So this is the value for the second and for the third row, for the second and the third account, and this is the latest version for the first account. The other two are garbage. So now,
the funny thing is that when xmax is 0, which means that it is the current version, we see A as aborted.
Yeah, probably. Yeah, this is how it treats. I think that flag, just was set. I mean, like, probably you can just disregard this flag if generally what it means. If let's say xmax is 0 and this flag A is set, and probably just you can disregard
because
it
that's the current value.
Yeah, this is
they are committed. You don't have ongoing transactions there.
Yeah, this one is aborted, meaning like xmin was 745, but there is an additional flag of A, meaning that this version of the row was never committed. It was basically aborted. That's why you don't see that you don't see this ID in xmax, because when you update a record in Postgres, like let's take this example, you see that this is the latest version for the account number 1. And it was introduced by this transaction ID. This same transaction also deleted this version of the row, the previous version of the row, which means that in PostgreSQL with MVCC, an update is effectively delete plus insert. You delete the previous version of the row, like that was the previous version of the row, and also you create the new version of the row. So this is how it works. Okay. Okay, let me see. We have a question from Jiva. Does Postgres act transaction-like operation for non-transactional operation? For selects, I think that for selects we don't start, any implicit transactions, right? Right, Frank?
We don't start, but we read as of a read time that is transactional. I don't know exactly what is behind. Basically, there are no non-transactional operations in Postgres. Or maybe if I understand the question, maybe this says that internally there are many versions non-transactional, and it is made transactional with those xmin, xmax, and the transaction status.
Yeah, might be. Also, it might mean that, let's say, when I do execute update, right, and I just execute, because let's actually move forward, and I will show this. That might also answer this question. And Jiva, feel free to clarify. Let's say that I want to update, like, because the next question is what happens with this garbage. I have just 3 rows that are visible, but I have 2 dead rows. I no longer need them. Let's do this. Let's say that that's a payday and everyone gets some extra money on their bank account. Let's do this. Update account, set balance, current balance, plus $100,000 of money type, and we applying this to every account. So when you, Jiva, when you execute this request, let's see that it's not executed inside of an explicit transaction, but internally, Postgres certainly studied the transaction for the update. And how do I know this? Now, if I execute the same select, take a look at this one. That was the transaction ID for this update, so it started, and that was one transaction. That transaction introduced the new values for those accounts. We have these accounts here, right, from account. So we've got, everyone got extra money, and this is those values. The rest is garbage. How do you know this? This transaction that created these three new versions of the row, 749, it also deleted the previous latest versions, like this one, and that one. Okay. So, and also interestingly, you see this garbage. You have this dead tuples. All this is no longer needed because I no longer have any other transactions running in parallel. And if you keep updating, let's update more money. People just want to get more money. Let's see what happens right now. I just certainly have, just 3 accounts here. 3 rows are visible. But if I do heap and take a look at this internally, this is what's visible to the application, and these are the dead rows. They're just wasting our space, okay, and they're wasting our memory. And but this is done for good reason, because you don't want to have any data inconsistencies when you execute transactions and queries in parallel. That's why Postgres does this for the multi-version concurrency control purposes. Now, next we will talk how this is garbage collected. We've got a follow-up question from Jiva: transaction begin operation commit. Non-transaction. Yeah, I think this is what. Yeah.
Okay, yeah. So non-transactional is actually transactional. It's auto commit, the right term for it. If you don't say begin, do your multiple statement and then commit, it will still run in a transaction, but an automatic transaction in auto commit. But basically, it's the same, a single statement, but it can update multiple rows, and then the statement will start a transaction behind.
Mm-hmm. Good. And Frank, as long as you started answering the questions, how this garbage get collected? Give us quick.
So,
intro.
as mentioned by Jiva, there is vacuum, but even before vacuum, Postgres can do some clever things, because if you come back to the same block and it detects that there are some dead tuples taking space there, it can remove the data. It will still hold the entry for it because there are still indexes pointing to it, but it can at least clean up some space, which makes it available for new updates or inserts. So that's one thing. Even before vacuum, some space can be cleaned, but the real cleanup means removing the dead rows, removing the index entries pointing to the dead rows. This is done by vacuum, which runs automatically, maybe not frequently enough if the tables are updated very frequently. So that's something to tune. But basically, vacuum does a very hard job going through the table, finding the dead rows, and for the dead rows, removing them. But worse, it has to go to all indexes that point to this row to remove the index entry. So it's not a light stuff.
Yeah, it depends. Yeah, it also depends on the type of vacuum, as you said. We have usually by default, you don't do any of this because Postgres has that auto vacuum. Yeah. And this is sort of like the standard vacuum that tries to start in background based on different metrics and heuristic. It can be your like storage size. There are different parameters. It can be frequency, etc., etc. But basically, there is the auto vacuum. It will not start on my Postgres instance right now because my database is just nothing. In Fox is just literally just several versions of the rows. Plus, what we will see, let's start that vacuum, but we can make sure that we can execute that vacuum that basically just iterates through the tables and sees like what space is already unused, right? It labels that space so that it can be reused by future data. All you need to do is just execute this vacuum command, and you can define just the table that you want to execute it. So now if you come here, take a look at this. Those are 3 versions of the rows that we see when we execute select star from account. And this is basically the free space that is available. I don't know like why this is not labeled as unused. Probably it still can be reused, but generally what it means is that if there is any reference to these are the very first versions of these rows when you created the table and created the first versions of the rows. If there is any reference to these versions of the rows, then basically jump to 17th for this one, 15th to this ones, etc., etc. But this space can be reused and Postgres will respond. This is what Frank is saying. For instance, let's say that where is my account? From account where ID is 1. So this guy is lucky and he won a lottery. So we can say this update account set balance balance plus $5,000. Okay, why not? Everyone won. Okay, everyone won a lottery. But anyway, now if you take a look at this one, take a look. This space was reused by Postgres. Okay, it was marked free, and this is the page. It's one of the pages that Postgres allocated from memory and from storage, and it was reused. So this is the new versions, and these are the previous versions. You can see that the transaction ID that created new versions, and then the same transaction deleted the previous versions. So the space can be reused. And usually it's okay because, and this is actually what happens if you are familiar with Java or like other programming languages that also use garbage collection. Usually garbage collectors, they're just trying to map this to find that available space and then reuse it. And sometimes you can deal without that fragmentation because this space is not defragmented, meaning that, right, you have, so right now you have these versions here, but probably like this one is, they're not just moved to the top. And we have the full vacuum procedure. The full vacuum, what it does, it will iterate through your database objects or through your table, and it will clean that unused space, and also it will move your active visible rows to the top of the storage of the memory. And then this is how you defragment the space, and then you can reuse, Postgres can return that space to the operating system if necessary. How you execute it, it's all simple. You just say vacuum full account table. And now if you take a look at this one, you no longer have that. You just have what you have.
Very simple, but be careful. This one takes an exclusive lock on the table because it rewrites the table. So this one, you don't run it online.
Absolutely. So they are doing this for the sake of experiment because we want to see how MVCC works internally, how vacuum works, because usually you just want to rely on that auto vacuum, just standard vacuum that starts, goes, labels available space, and then reuse, and then lets the database reuse it. But sometimes I think that, yeah, like usually if someone decides to run full vacuum, then there is a very good reason, and usually a database administrator would be doing that.
Or there are also some extensions or tool like PG Repack, PG Squeeze that tries to do the same online, maintaining multiple 2 tables and to do that online. But yeah, it's full reorganization. Yeah.
Yep. Hopefully it makes sense to you folks. That was the quick intro to the PostgreSQL MVCC internals. What we saw that every row in Postgres has a header that stores various columns like xmin, xmax, etc. that are needed for the MVCC to function. And then eventually, whenever you update your records, insert their records, or delete records, then new versions of the records are going to be created. And the old versions are garbage collected by Postgres. Now, we have 15-20 minutes left, and I think that's a good chunk of time for YugabyteDB. Like, how is it related to YugabyteDB? YugabyteDB is a distributed version of Postgres. We reuse the Postgres query layer, but the storage layer is what makes us unique, meaning that our MVCC implementation is a little bit different. And so now I'm heading over the screen to you, Frank. Just please show us the internals of the YugabyteDB MVCC engine, because from the application standpoint, it's all the same, right? Yes, whether you're connected to Postgres or YugabyteDB, primarily all the same requests, the same operations, but internally the MVCC functions a little bit differently.
And we will do exactly the same, but with Yugabyte, which means that the SQL statements are the same, but the tools to look at it are different because we don't have pages, we have key values in RocksDB. So let's show that. I've started a simple cluster on Docker here, very simple, and I will connect to it. So let me, I use YugabyteDB to connect. Usually I connect with PSQL. Why not using YugabyteDB connect? I will create a table that is very similar to yours. I've added a text comment because text will be easier to view. I'm not a big fan of Money data type, but why not? I insert a single row and I've put a comment that I will find in the file because my goal will be to find within the different files where this data goes to see exactly the different versions. So very simple, very similar to what you had before. I missed the beginning of the live, but I was aware of what you were showing. And if I look at Yugabyte status, I know where is my data directory. And to find my row, let's do something very simple on Linux level, a grep, recursive from it, looking from this text. And I find a file with it. First thing, here I started a cluster with no encryption. In production, you should use encryption. And the reason is that without encryption, the data is visible from the OS. Here I use that to find the file. So this is not a data file, this is a wall, write-ahead logging, because this is the first thing that is written by Yugabyte. We store table rows and index entries in LSM tree using the RocksDB implementation with a lot of optimization. And the first level is in memory, which means that the data, my insert, is only in memory, but protected by write-ahead logging. As the name implies, it is written ahead. So it is the first one that is written. Okay. Now I can use strings in Linux to see a bit more what I have inside this file. And I will grep to see my deposit comment. Of course, I need a pipe there. Of course, it's difficult to read because it's written in RocksDB format in it, in SST file, but you can see that I have my character string. This says that it is a string. And yeah, there is also some information about the columns, but that's different. Okay, this is a log, write-ahead logging. We have also a tool, log dump, that can show the content, read the content, show the content, again, if it's not encrypted. Sorry, I have my mouse that's pasted too many times. Taking the file, copying that.
Yeah, this is we don't have a page inspect while you're doing this. The page inspect extension basically doesn't make sense for YugabyteDB because YugabyteDB is effectively a distributed LSM base tree storage, right? While page inspect was created for the storage of architecture of Postgres, and Postgres by default uses this kind of heap structure for the data and also B trees or other types of indexes for your indexes. And folks, I see questions from Oleg. Oleg, I see your questions, and we will address them a little bit later. So stay tuned.
Do you use LSM3 for indexing data
You want
to
to answer,
file?
right?
We use LSM3 for everything, and we will look at the LSM3. For the moment, this is not the LSM3, this is the write-ahead logging. We don't use the wall of RocksDB. We use wall at higher level because this is also what is distributed to many nodes. So basically, in the wall, you see document and sub-documents with the information, the value, and the comments that are visible when decoded with logdump. But now we want to see the
And also, well, as long as you answered the
Yes,
second
35. Yep.
question of Oleg, his first question was, is it possible to run vacuum concurrently? It depends on what type of vacuum you're talking about. If you're talking about the standard vacuum, like the standard vacuum basically runs in parallel. I'm not sure, like, yeah, I'm not sure what type of logs. I don't remember what types of logs the standard vacuum puts, but those are not exclusive table logs, meaning that it's pretty much doesn't impact too much your
Yeah.
application workload, and that's why we have that auto vacuum. It just starts in background, and you can certainly configure it. But the full vacuum that just defragments the space, and you can return that space to the operating system. That one, no, that one doesn't work concurrently, and basically will put exclusive logs on your tables, meaning that you will not be able to execute updates, etc. But if it's truly necessary, you can always just, at least you can run that full vacuum on a per table, or per, I think per partition even basis. At least this way you can distribute it. Hope it makes sense.
Yeah.
All right, Frank.
So now we want to see the real LSM tree, not the wall. So I go to the place where they are stored. If I grep for it, I do not find it. I find only the wall. I need to flush the memory table. This happens with a lot of activity, but in my small lab, it stays in memory, but I can flush all tablets, and then SST files should be written from what was in memory. And then if I search for my value, I find it in the wall as before, but also in a SST file. And now we will look at what is inside this SST file.
Yeah, while you're showing, like, yeah, feel free to show. I will explain to those who are not familiar with LSM trees yet. Here is YugabyteDB doesn't do anything, super unique, because usually LSM trees, like whether you like you if you also have experience with Cassandra, with LSM trees, you just write to mem table, and that's in memory version of LSM tree first, and then you commit to write a headlog file. This is how you ensure data consistency and durability. And then, like, over the time, periodically those mem tables are flushed to disk. And this is, as long as Frank's use case is very minimalistic as well. Those mem tables are not flushed automatically. That's why he forces to flush that mem table to disk, and this is how that SST table is created, so that we can see what's inside.
So let's look at what's inside with SST dump. That's a tool that comes with RocksDB, but we have enhanced it. I scan the whole SST files for this tablet. It is in the format of regular DB. If we have time, we will see the instance DB. But basically, I'm looking at the current directory where there are those SST files. I add a formatter because if we use an optimization that is packed rows, it needs some metadata that is in another directory. But we'll not go into the detail, just dumping what I have into the file. And it is a key value data store there. The key, so I inserted a value where the ID was 1. So the key is 1. Because I'm hash sharded, it adds a hash value in front of it. And that's the key for my row, my table row. We store the rows in their primary key. That's different from Postgres that uses heap tables. So here I have only one primary key. So for the key, I have the information system colon ID. I have the information that there is a row. And then for each column, there is a sub-document. Everything is compressed. Here, SST dump shows the detail.
It's more like JSON, right? It's very kind of, yeah, familiar to the JSON structure when you have the top level key, and under the top level you have, something that goes down.
And I have then the two values for the two columns. So you need to go to the metadata to have the name of the column, but the first column was the balance. So the money, you can see that the money data type stores in cents, and the text is there. We don't have xmin, xmax, and we don't have CTID. As you had in Postgres. The equivalent of CTID, the place within the storage, is the key. The equivalent of xmin is the hybrid time. This is the epoch. We can see date. I think this shows the date from an epoch. So we use the clock. But this is a bit too
Yeah,
much.
we use hybrid curve, hybrid clock time. It's it's a mix of physical clock, prime Lampert clock. Folks, we're not going into details. If you're curious, just write us down, and we will share a wonderful article with you that was written and explains various
Big
implementations.
advantage compared to
Yeah.
Postgres is that we don't have this transaction ID wraparound, because this is always increasing clock. And because we have nodes in different places, there is this hybrid time that is synchronized between the nodes. So basically, this is how the versioning is done. Each row, even each column, has a version, and this is version with the time. Okay. Now we will do a bit more on this table than just having
Also,
one row.
Also, just to make this connection with Postgres, you remember that like you mentioned that X means X max those unique IDs that are generated for transaction, and then every version of the row is labeled. When you execute, let's say, your operation, that operation will see, as long as it's Postgres, it will see all of the versions of the rows that were committed before the ID of the current operation. So basically, you will not see like what's coming in the future, because you can start your transaction, and that's a long-running transaction. And while this transaction is running, there are other updates that happened in the database. And that transaction that has, let's say, ID 5 in Postgres, it will not be able to see changes that were introduced by the transactions with ID 6, 7, and 8. So this is how Postgres creates that view of snapshot. In YugabyteDB, we use that time, hybrid clock time. We don't use those transaction IDs. We use hybrid clock times, meaning that the transaction started at 11 a.m., 1 minute. It will not see all the changes that happened, let's say, a few seconds later, because that transaction, just it wants to see what was before.
I just add 2 more rows to see them if I SST dump. So I need to flush again, because this goes to the memory table. I flush, I see an additional SST file, another one, because it's flushed to a new file, and you see the 2 new rows there. If I update,
yeah, update is the most
I
interesting,
flush.
because update is interesting because, folks, you remember when we were updating things in Postgres, I was updating just the balance column, but Postgres was creating a complete version, a new version of the entire row.
Yeah.
This is how Postgres functions. Let's say that you have a row with 10 columns, and you just update one column of those row, still the full copy of the row will be created. So this is how Postgres
in
functions.
Postgres. But here, what I have, the new flush, what I have is only the new version for the column. For column 1, the new version. So this is small. But then, so here I flush manually. In real life, it is flushed after it reaches some size. But at some point, you don't want the increasing number of SST files, because if I want to query for this value for account number 1, then it has to open the 2 SST files, look at the time, and find it. So this is why in the background, there is some compaction happening that I can force manually.
And this is actually, this is addressed to the question of Jiva. So how LSM engine LSM do vacuum? It's called compaction. Yeah, and Frank is gonna answer this right now. And also a quick housekeeping, folks. We're already beyond the hour that was scheduled for this live stream. We all understand that you might have some work to do, or just to get back to your family and friends and hang out, which means that we will be great. We will be appreciate if you stay with us, because I think we need 10 extra minutes, and we will be able to answer your questions. If you need to go, the recording is going to be available on YouTube. Okay.
YouTube, yeah. So here I have a brand new SST file. The other are not needed anymore. A brand new where everything is there. And now you can see why we don't need a X max, because everything is together under the same key. I have the 2 versions there. So it's easy to find the latest version without random read in different places when it is compacted.
Cool.
Okay.
So this is how you can reduce the bloat. And I mean, like, it doesn't mean, folks, we don't want to make the statement that Postgres is worse than YugabyteDB, or YugabyteDB is better. No, like systems were designed for different purposes. And as long as YugabyteDB runs in a distributed configuration, we already take, by definition, we take the latency hit of the network. That's why we do as many optimizations as possible at the storage level, right? At the query engine level, for instance. That's why we want to update as a minimal as the granular chunk of the record as possible. That's why we want to get only to just when we do joins, we want to use the batch updates. So that's why it doesn't mean like something is better or worse. It's basically just a little bit different architecture that was created for distributed and highly available applications. So just
And also this was created when the storage is SSD.
Mhm.
Postgres and many traditional databases are using block and pages, because when you are on mechanical disk, you have this latency where you want to read full blocks, get that in memory. Here, reading at specific place on multiple file is not a problem, not too many because it's compacted. So now we still have, so compaction here compacted everything together, clustered everything together, but I still have the two versions for the exactly same reason as with Postgres. We have the two versions because maybe another query has to read the previous version. And by default, we keep them 15 minutes. There is a parameter for that. I can see the parameter. It's called time history retention interval. By default, we keep the version 15 minutes. Here for the demo, because we are already late, I will set it much lower, like 10 seconds, and do a compaction. So I simulate the fact that I don't need the intermediate versions anymore, and a compaction happen. I put back the value just to be sure. And now if I SST dump, I can see a new file because it is compacted. And this new file doesn't have the intermediate version, just a new one. So we have the first version for the command that didn't change. And for the balance, we have a new version there. We don't need the intermediate version. So
and what
it
happened
looks
and what
like, sorry,
yeah, and what
go on.
happened to the previous versions of the SST files? Are they still there or are they already deleted during the compaction?
I think they are deleted except if we use snapshots. So
Oh, yeah, we might have
they are
snapshot.
deleted. They can stay if we use a snapshot to be able to run point in time recovery or for backups. Then maybe they can stay. But yeah, they are removed. So compaction is there to reduce the space amplification and also the number of file, and then the read amplification, not having to read from too many files. So
Okay.
yeah, that's very similar to vacuum in the way it is garbage collection, but it is at a lower level. It doesn't compete with the ongoing activity. It is run in the background. It is throttled not to take all I/O, and just keeps the number of SST file to a minimum.
And there is a question from Jiva. So YugabyteDB does compaction native way of LSM engine do, and why write-ahead lock also do the same because we trace records. I mean, like write-ahead lock and that LSM based structure, they coexist. Like whenever you're actually discussing, whenever you're thinking, whenever you're hearing about, let's say, LSM based database, it can be YugabyteDB, it can be Cassandra, there are others like RuxDB. Those databases, they have write-ahead lock file. Why? Because when you update any record in your database like YugabyteDB, the update is written to write-ahead lock file for the same reason why it's written in Oracle, Postgres, or MySQL. You don't want just to lose this data. And then this update is written to the memory, to the mem table. Once this happens, write-ahead lock and mem table, the database YugabyteDB acknowledges the transaction and your application can continue executing other requests. But then this mem table keeps growing. It keeps growing, it keeps growing, it keeps growing. At some point of time, it will be flushed to disk. And this is what Frank was showing. when it's flushed to disk, the LSM-based engine creates those SST table files. It's like sorted string, whatever, I don't remember, files. And they also will keep old versions of the rows. This is what Frank was showing. And those kind of files will be created periodically. And eventually compaction, it's like the vacuum of YugabyteDB, it will start once in a time, like based on different criteria, it will merge your SST files, removing all the unused records. Write-ahead log file is separately, and write-ahead file, I think, also can be truncated, right? It can be truncated when you no longer need, let's say, some of the chunks. It also depends on your probably point in time recovery settings, etc. But write-ahead.
Actually, the write-ahead log is not needed anymore when the mem table is flushed. It's not needed to recover, but we keep it because we also replicate to other node for high availability. And if another node is disconnected, let's say for 5 minutes, and comes back, it wants to get the latest changes. And those come from the write-ahead log. So the write-ahead log has two reasons. One, to protect the memory table. If the node crashes and then restarts, then the memory table can be there again from the log, but also to help short disconnection with the Raft followers, so that when they come back, they can get the latest changes. If the disconnection is more than 50 minutes, then it's probably faster to just read the whole tablet. Tablets are kept small because it is sharded, rather than reapplying all the changes. So basically the whole, we keep it by default 15 minutes to be able to come back quickly when a follower was disconnected. And for the SST files, yeah, we use the compaction of RocksDB, but with some additions. For example, this about MVCC. RocksDB by default doesn't have an hybrid timestamp. It has a sequence. So we added a few things. Also, not for the SQL interface, but for the CQL interface, we do some TTL, some time to live, where the compaction can remove the rows that are expired. So we have improved a lot on top of RocksDB.
Yeah, this is a broad topic. It's very broad. Yeah, we definitely no longer have time to go deep in the woods. But let's finish with MVCC. And hopefully GWrite addresses some of your questions. If now, you can always find us on Slack, etc., and we can provide you with more resources on answer questions. So Frank, what else? What else did you want to show? Anything else with this demo?
So yeah, very, very quickly, just because you did a transaction with beginning transaction, let's see where it goes, because for the moment, we have seen only committed changes. I want to see the uncommitted changes. So I do an update, I do not commit it. I flush it. If I look at the SST dump, I have nothing more because it's not committed yet. If I look at the directory where my LSM tree was, I have a sibling directory there called intents. And this is where we put the provisional records, and we have SST files there. So actually, we have two LSM trees, one for the committed data and one for the intents. And here I SST dump my simple update, and you can see a lot more there. You can see the similar information, the subdoc key with the value, but with more information. For ongoing transaction, we acquire some locks that we don't need after when it is committed. But other sessions, when they see that there is an ongoing change on this, they must look at the log and maybe wait for it. So we have more information about the transactions. And that's also what is really nice with this architecture, because in Postgres, in Oracle, in many MVCC databases, this log and transaction information stays and must also be cleaned out later. Here, when it goes to the regular DB, it's all clean. We have this intermediate level. And again, it's different architecture because we can do that, because our LSM tree works, the M for in LSM3s for merge. It can very efficiently read from multiple files. So why not read from the intents and the regular DB at the same time? And then when you commit, it doesn't have to wait on it. It just set the transaction as committed, but in the background, YugabyteDB will take the provisional record for what is committed and put that in the regular database. So if I commit, if I flush, I SST dump, not the intents, but the regular DB. Now I should be able to see my change, which I forgot. What did I do? I did an update on all of them.
You incremented if you.
Oh yeah, I did an update here, and I see this one there. Yeah, it was an update on only one row, I think. Yeah. So yeah, that was very quick, but just to mention that we have also tools to go into the detail, like pginspect does. We have SST dump. I think we have documented, but if you just type help, there is more information. And of course, we can help on the community Slack or any channel.
Excellent. Yeah, even though we are over our planned 1 hour, but I think that this live stream was useful for you folks, for those who are interested in the database internals. And yeah, very thankful to all of you who made it to this live stream today. And those of you who would be watching us on demand, just enjoy. And if you have any questions to us, you can find me and Frank on Twitter or community Slack.
And if you have other questions, we can go into more detail on Yugabyte, on Postgres in other open hours.
Exactly. That's the point, because even when you started explaining this write-ahead log, how write-ahead log file is used today, right? You're like typically like standard like single server databases use it for the durability of your data, but we also use it for the Raft consensus protocol for the replication. I mean, like even this topic deserves a separate live stream, and then we can compare, let's say, why and how the write-ahead log file is used by Postgres, etc., and then how by YugabyteDB. So you can share with us your feedback, what you would like to learn. Again, you can find us on social media, you can find us on the community Slack. Just find us, tag us by name, and we'll be happy to stay in touch. So in the meantime, yep, we have Jiva. Thank you for kind of coming and asking your question, because you helped us to guide the conversation. And Oleg, also thanks a lot to you. Probably you will be now you know what vacuum is, and you know like how to use it if necessary to fine tune it for your deployments. And Ashwar, certainly thank you for being our not just consistent, but our regular guest on all of those live streams. We really appreciate your time. Any last questions, my friends? I'm just counting in my head to 10. If I don't see any last question, then we will close this live stream. I'm checking LinkedIn now. Silent here. All right. Thanks a lot, Frank. Thanks. I knew that you would be able to make it. I knew that you would.
Yeah, really sorry. Yeah.
It's okay. It's okay. The beginning was at least we spent less time, bragging how we met each other at Scale conference. But I shared some of these. All right. Thanks a lot, everyone. Yeah. Thanks, Pete.